we go. All right, so today we're going to write equations. We've done this before. We did it when we have linear data. And because we've done linear before, we're going to do it again. You might see linear in this lesson also. Good to see right there. Give me a moment, I'll grab it. All right, so the first thing that you're going to do is you're going to look at this data, and you need to make sure that your x's are evenly spaced. So right now, make sure that your x's are evenly spaced. Are all of our x values evenly spaced?
Yep.
They're all one apart?
Yeah.
Right. The next thing that we're going to do after that is we're going to find the differences for the y values. So I'm going to look from 9 to 4. What do I do to 9 to make it into 4? I subtract 5. How do I make 4 into 1?
Subtract 3.
I subtract 3. How do I make 1 into 0? Subtract 1. Now, if you're not sure how to get these numbers, maybe they're not as easy as this, maybe they're harder numbers, what you could do is you take the second number, subtract the second number minus first number. So I would take 4 minus 9, and that would give me negative 5. I would take 1 minus 4, and that would give me negative 3. So you could subtract them if you're not sure. So what we have done is we have found what are called finite differences. We're going to write that down so that you have seen it before. These are called the first finite difference. That is a finite difference. What we are trying to get to is we're trying to get to when the finite differences are all the same number, which these are not all the same number. So what we're going to do next is called the second finite difference. So we're going to take our previous differences and now find what you do to negative 5 to make it into negative 3. So if you're not sure, you could take negative 3 subtract negative 5. You take the second number minus the first number, and what does that give me? What do I do from negative 5 to make it into negative 3? I add or subtract? I add 2. How about from negative 3 to make it into negative 1? Add 2. Negative 1 to positive 1. Add 2. Add 2. Add 2. That's our second finite difference. This time they are constant, which means the same number. Our goal is to find out how many finite differences it takes before they are constant. That tells us what kind of regression feature we will use on our calculator. So if it is constant the very first time, if it's one finite difference, then we would use linear regression. That means it would look like what shape when we graphed it? A line, right. And in our equation, we would have just an x. For the green ones, the second finite difference, this is going to be quadratic regression. And when we find our equations, there will be an x squared in it. Does anybody want to guess, if we had to do 3 finite differences, what kind of equation we would have if we had 3 finite differences? We would have x cubed. That is totally right. Does anybody want to guess if we had to take 4 finite differences before they were constant? It would be to the 4th power. Right. So the number of finite differences you take is the exponent that the x gets. And on the calculator, we're going to use either linear regression or quadratic regression. So the very next example is a U-try. And we just need to figure out what kind of regression we would use. So I need you to do exactly what we did on the first one. Find the differences to see what question 2, what the student practice, what regression we would use. All right, so you will see in your homework there is a section that says you have to determine if it is linear or quadratic, and then it asks you to find the equation after that. So if it is quadratic, you're going to do what we're about to do. If it is linear, then you're going to do almost all the same steps. We've done linear in here when we did section 1.4 in the book. So it's kind of, we're revisiting things we've already learned. So now we are on example 4. In example 4, I've already had you go plug in the data into your calculator. And I'm going to pull up my calculator so that we can watch me do it on the calculator too. In this big area, this big space, we are going to write some answers, but you can also write the steps of the new stuff we're learning today on the calculator. You can write the steps. Yeah. This table shows fuel efficiencies of a vehicle at different speeds. Write a function that models the data. Use the model to approximate the optimal driving speed. So we certainly want to be able to drive and use the least amount of, or I should say get the most miles per gallon, right? So that this table is going to help us do that. We went to our calculator and we went to stat. And then we went to edit, and we typed in all of our list 1 and our list 2, which is our x and our y values. So now we are going to graph this, and we're also going to find the equation. All right? Let's go ahead and graph it first. When we go to graph these, we need a window that shows all of these values. So let's go to Window. And our x minimum, what is the smallest x in our table?
20.
20, well, let's go smaller than that. 15? 0? I mean, you could go 0 miles an hour. Okay. What is our highest x? 70, so we better go above that, like 75. And for my scale, I'm just going to count by 5s. Then our y's, what's our lowest y?
14.
That's kind of weird. I'm just going to go 0. And our highest y?
25. 28.
All right, I'm just going to go to 30 for our highest y. And I'll count by 5s again. Now, it's been a while since we have graphed the statistics, so we're just going to go through the steps to make sure everything's still set up for us to do statistics. You shouldn't have to do this every time. But let's go to stat plot. To get there, we do second y equals. And number 1, we're going to choose that one. And we just need to make sure that we turn it on, because it's not going to work if it's not turned on. Make sure that we are on the scatter plot, that you have list 1, list 2. You can choose whatever color you want. Well, sorry. You do have colors. It's black and white, basically. And then hit graph. And if you've done everything correctly, you should have a graph that looks like mine. If you haven't, then you got to stop me before I go on and or work with somebody near you. If you have an error, if it doesn't look like mine, you got to stop me. So you're gonna catch up, and then Colin, you can go back and watch this later. All right, now we're gonna get our equation. So this is to get our equation. Again, this is review of what we've done before, except for this time it's a quadratic rather than linear. To get our equation, we go to stat, and then we're going to calc this time. We're going to calculate the equation. And not linear regression, but quadratic regression number 5. And then hit enter after that.
Calculated.
Okay. You have more numbers here than you have here. So something happened. There- he's not in order. There's too many numbers. So check this out. Go up to the yeah, you got 2 extra numbers. Or you didn't type enough. So 20. Got 2/3. Do what we're doing now. Go to stat. Okay, so we went stat. I'm going to do it again. Sorry, so we can catch everybody up. Stat, and then we this time went to calculate, and we're choosing quadratic regression, and then you hit enter, and it should give you the equation. So we're going to go to example 4, and we're going to approximate our equation right there. Write down your equation. It asks for the equation. And I'm just rounding. So negative 0.0141x squared plus 1.366x minus 7.144. There's my approximate equation. All right, now what I'm going to do is I'm going to teach you something you haven't seen. This is how to copy the equation to the y equals so we can graph it so I don't have to go and just type in that long equation. We're going to copy it. So on your calculator, and we're going to write the notes down too. On your calculator, if you just go to y equals to start. Go to y equals. And sitting right here, it needs to be empty. Make sure it's empty. Make sure it's all clear. Make sure your little cursor is sitting there at y1. You got to do that first. So we're going to go to y equals. So on your paper, if you're taking notes on how to do this later, write y equals. So that's the first button we go to. We go to y equals. Then from there, you're going to find the button that says bars, B-A-R-S. Bars. You're going to click bars. It is under the arrows, bars. And then I'm kind of writing this down as I do it. So you're going to click bars, and then you're going to choose statistics, which is number 5. You're going to choose statistics, number 5. Once you've chosen statistics, you'll see this screen that pops up. We have to arrow over twice to get to EQ. Arrow over twice to get to EQ. And then choose reg EQ. Regular equation, reg EQ. And then as soon as you do that, it copies it for you. If you've gotten to this point, then hit graph.
Whoa.
Almost, right?
EQ.
Thank you.
Yeah.
So if I'm going too fast, you can, of course, go on Canvas later and watch this video again. So we have graphed the equation. The next thing that we're going to do is we're going to find the optimal driving speed. To find the optimal driving speed, we want to drive as fast as we can, and we also want to get the highest miles per gallon. So we are looking for the maximum point. I'm going to show you how to do this via calculator, not by algebra. I'm going to show you how to do this on the calculator. So this would be another place where you might want to jot down what we do. This is to find the maximum. We're going to go second trace. Second trace, you will see a list come up. And oh my gosh, one of them says maximum. We are trying to find the maximum point.
Where's trace?
At the top. Very top.
Right next to graph.
Right next to graph. Second trace, right next to graph.
Oh.
Okay.
Insane.
All right, so second trace, we're going to choose number 4, which is maximum. Now, this is where you need to listen, because I'm going to lose you if you're not paying attention and doing this with me. It says left bound. That means we're going to draw a line. Actually, we're going to make a boundary on the left and the right. You'll see. A left and right boundary that is telling the calculator, look between these lines. We're going to tell the calculator, look between these lines. So you need to go to the left side of the maximum point. And I don't know where the maximum point is, so I'm going to make my boundary bigger than I think it needs to be. So I'm going to arrow them over until I'm definitely to the left of that middle. And I hit enter. And a line pops up. Then it says right boundary. So now I'm going to arrow over till I'm definitely past the right of that maximum point. So I've given myself a nice large window. And then after I hit right boundary, it says guess. All you have to do is get closer to it. You don't even have to be perfectly there. And you need to hit enter after it says guess. It will then tell you the maximum ordered pair, the maximum point. Yeah, just give you an order.
What do we do for games?
Yeah, so now guess.
You just put
Get
it
as close as you can to where you think.
Yeah, then enter.
Put it in.
Okay, if you've done everything the same as me, you should have a maximum point at 48.4568585-ish. It's approximation.
Yeah.
And the Y value would be 25.9571. That is miles per gallon. So that would be our maximum miles per gallon that we could get. So we would go back to our question and write down that for the maximum, it's about 48.457 miles per hour. Gives us 25.957 miles per gallon. So that would be the optimal. Okay, I'm going to walk us through, it says student practice, I'm going to still walk us through the next examples. You may work ahead if you are understanding and want to go faster, but we're going to use our graphing calculator for 5, 6, and 7. So for number 5, it just says write the equation. It does not say we need to graph it, we do not need to find the optimal anything. It's just straight up find the equation. So I'm going to start, and we're going to go to our graphing calculator, and we're going to enter in the list. So we're going to go stat, edit. Now I have all these numbers in from before. To get rid of them, you go up, and you hit clear, and you hit enter. That is the quickest way. You go up, clear, enter. Now I'm just looking at my x values for list 1. So what are my 3 x's for number 5? -1, 0, 2. And I look at my list 2, those are my y values. 4, 1, 7. Now, all we have to do is find the equation. So how do we find the equation? Stat, calculate, 5. Quadratic regression. Enter. So we get our our A, our B, and our C, and we just plug it in. I'm going to write the equation down using those values. And that's it for that question. Question 6. The table shows the estimated profits Y in dollars for a concert when the charge is X dollars per ticket. Write an evaluated function to determine whether the charge per ticket should be what the charge per ticket should be to maximize profit. If you have a business someday, you certainly want to get the most profits possible, right? So you would want to maybe use some of this stuff to figure out the best ticket price to get the most profit. Before we do any of the calculator stuff, just to review, how do I know if I'm using linear or quadratic regression? What are we going to do?
The second one minus the first
Second one minus the first one. So we got 6,500 minus 2,600. $8,600 minus 6,500. 8,900 minus 8,600. Did I do something wrong? No, I didn't. Just kidding. So I did my first finite difference. I know it's not linear, so I'm going to do my second finite difference. I didn't really leave you a lot of space, sorry. But that's okay. It's okay if you write on top of another one. So my second finite difference, and this is telling me, ooh, it's constant, so it must be quadratic. So now let's go to our calculator and enter in the list 1 and list 2. If you know what to do, work ahead of me. I'm doing it all so that you have this video for later. When I go to my calculator, I'm going to hit Stat, Edit, and I'm going to enter in my list 1 and my list 2. Oh. Okay, after I entered that in, then I'm going to go to my window, and I'm going to choose a window that shows all of the data. So my x's, looking at my lowest x, probably go from 0 to 20. Count by ones. My y values, looks like I'm going to go from 0 to 10,000. Count by thousands. I also need to go to y equals and clear out my other equation from our example earlier. Don't want to confuse it too much. Then when I hit graph, it does look like a parabola. So then I'm going to make my equation. It does look like a parabola, so I'm going to make my equation. To make my equation, I do stat, calculate, quadratic regression. Enter. I'm going to write that equation down, and then I'm going to graph it. But I'm going to end up using it copied. I'll go over how to copy it again. I'm going to go ahead and write that equation down. And then again, to copy it, we have to go to y equals first. You have to be in the y equals, then you do vars. And we choose statistics, arrow, arrow, regular EQ. And it copies it for me. Puts the x squares in and everything. Then I can hit graph. Finally, we need to do the optimal. Maximize profit. So I need to find the maximum. So we're going to do second trace. Maximum is number 4. And we have to choose a window, a left and right boundary, for the calculator to look for this maximum. So I'm going to choose my left and my right bound. And then guess, it doesn't have to be perfect. Just go close to it. And then make sure I hit enter after each one. Depending on what window you use, your number for your x value might be slightly different. The answer should be 10. But depending on the window you use, sometimes the calculator is off just a tiny bit. The answer should be 10, 9,000. That's what the answer should be. If you get like a number like this, it's okay that we round it. The answer really is 10, 9,000. So we charge $10 per ticket for $9,000 profit.
If they give you some tickets for $2, you will only get 2,000.